Hello everyone, myself I am Divya from Department of Chemistry, working as Assistant Professor in Marri Laxman Reddy Institute of Technology and Management. Okay, so today we are going to discuss two topics, that is fuel cell and solar cell. But before this, we are going to end up with a topic that is lithium ion batteries that we have discussed in the last session. So from the last session, the continuation part is lithium ion batteries. So here the topic is lithium ion batteries for electrical vehicles. Okay, so nowadays when we have seen any electrical vehicles, you might be seen the name like lithium ion, right? So the electrical vehicles are used are made by a lithium ion battery. Okay, so why we use a lithium ion batteries means it is a most high energy per unit mass relative to the other electrical energy storage systems. Okay, so in most of the vehicles we are using this lithium ion batteries nowadays. Okay, and also these are having a high power to weight ratio and also to the high energy efficiency, and also it gives the good high temperature performance and also the low self discharge. Okay, these are some of the advantages of lithium ion batteries. That is why we are using this lithium ion batteries in our electrical vehicles. Okay, and the most components of the lithium ion batteries can be recycled. Okay, whatever the components we use in a lithium ion battery, that can be recycled. That is why the most today's electrical vehicles use the lithium ion batteries. Okay, so the batteries are made by a lithium ion battery. Okay, next, in recent years, electrical vehicles are using new variations on lithium ion chemistry that sacrifice the specific energy and specific power to provide the fire resistance. It is also a useful thing in our electrical vehicles. And also coming to electrical vehicles, okay, the first major advantage is the environmental friendly. Okay, because it does not give any pollution out. Okay, it is free from pollution. And also the we can charge the electrical vehicles within a few minutes. That is why we call it as a rapid charging. Okay, rapid charging, and also it gives the longer lifespans compared to the other vehicles. Okay, so when we compare the electrical vehicles to the other vehicles in our market, okay, it is one of the most important is what it is a free of pollution. Okay, it does not emit any pollution or any toxic gases in the air, and also that is why we call it as a environmental friendly. And also the charging also can be done within a few minutes, and also the lifespan of the electrical vehicles are more. Okay, this is the about the lithium ion batteries to electrical vehicles. Okay, so till now we have discussed what are batteries and classification of batteries. Remembered like primary battery, secondary battery, and we have understood like what is a battery and how it is made up of, what is its applications or advantages. So before you selecting a battery, what are the things you have to keep in your mind? Okay, whenever you are selecting a battery, okay, these are the things you have to check before selecting a good battery for your use. Okay, so how to select a right battery? It should have good visibility. Okay, and also the safety is most important. Okay, safety, and also the energy density. Okay, you have to check for the energy density and also the power density. Okay, next is voltage. You have to check how many voltage it is going to give. Okay, and the most important thing is what? The cost of the battery. Okay, and also the shelf life. Okay, the lifespan of the battery. Okay, and also the operation life. Okay, and also the thickness, and also commercial availability. Okay, and we have to check whether the battery is available commercially or not, and also the temperature range, and finally it's a life cycle. Okay, it's a life cycle. These things you have to keep in your mind whenever you are selecting a battery, to select a good battery. Okay, these are the basic requirements for selecting a commercial batteries for the use. So next we are going to a other topic that is known as fuel cell. Okay, till now we have discussed batteries, right? Okay, even the fuel cell is similar to a battery, but some differences are there that we are going to discuss in our further slides. Okay, a fuel cell, okay, a fuel cell is also a device that converts the chemical energy of fuel into a electrical energy. Finally, the product it gives is electrical energy or the electricity, same as the battery. Okay, and also we have other definition is a fuel cell is a device that produces the electricity through chemical reaction between source fuel and the oxidant. Like, we'll understand what do you mean by fuel, what do you mean by oxidant or the oxidizer. Okay, so in our batteries or any devices, we have majorly three components, right? One is anode, second one is cathode, and the third one is electrolyte. Yes, so here also we are going to have this three major components in our fuel cell, that is anode, cathode, and the electrolyte. Okay, now you can see a picture on the screen, right? So the anode, near anode we take a fuel, okay. Near cathode we take a oxygen, So if you take any fuel cell, there you are going to see compulsory a fuel and the oxidizer. Okay, we call it this one as a oxidizer. Okay, why? Because this oxidizes the fuel. Understood? So what we are saying, it is a device that produces the electricity. Through chemical reaction. If you can see the below reaction, the reaction between the fuel and oxygen. Now you understood what is a fuel and the oxygen, right? So the reaction between these two, fuel and oxygen, it gives the oxidation products along with the electricity. This is for the fuel cell. Okay, this is a basic definition for the fuel cell. A fuel and oxygen will combine to give a oxidation product along with the electricity. Okay, so few of the examples of the fuel cells are hydrogen oxygen fuel cell, and the other one is methanol oxygen fuel cell, and other we have like molten carbonate fuel cell and phosphoric acid fuel cell. Okay, these are the examples for the fuel cell. Okay, so you understood what is a anode, what is a cathode, what is there. Okay, so if you take anode, see, simply we are going to have a fuel cell like this. Okay, this is your anode, this is your cathode. Okay, it will be having some inlet, Okay, so anode, cathode, and middle you are going to have a electrolyte solution. So what I said, at anode always who will be there? Fuel will be there. Next, at cathode, oxidizer, that is your oxygen. Okay, now we know electrodes are connected to a circuit. Or a bulb. Okay, and the ions, from where the ions will move? From the electrolyte solution, and the electrons will move from the external circuit. Okay, this is the basic construction of any fuel cell. It consists of a anode and the other one is cathode, and in between the cathode and anode we have a electrolyte solution. Okay, next, the part near the anode we call it as the anodic part, and here we call it as a cathodic part. Okay, in the anodic part the fuel diffuses, and in the cathodic part the oxygen diffuses. Okay, so this is a basic construction. What first we have a anode and cathode. In between these two we have a electrolyte solution, and we also call it this membrane as a PEM membrane. Okay, PEM membrane. PEM is nothing but proton exchange membrane. That separates the anode and the cathode. Okay, so this is how we represent a cell representation of a fuel cell. If you observe, the first one is what? Fuel. Okay, and beside the fuel or the fuel compartment, what we have? Anode. So that is the second one, anode. First one is fuel, and after anode what we have? This one. After anode we have is a electrolyte. Okay, and after electrolyte, followed by electrolyte, we have a electrode, that is cathode. See here, this is cathode electrode, this is anode electrode, this is anode electrode. Okay, so electrolyte is followed by a electrode, and later we have a oxidant. Later we have a oxidant. Later we have a oxidant. Once again I'll show you this representation. Okay, okay, this is your anode, this is your cathode, this is your electrolyte, and here you will be having a fuel, and here you are going to have a oxidizer. Okay, now you have linked to it fuel, electrode, okay, anode, and the electrolyte solution between it, and the electrode, that is cathode, and the oxidizer is oxidant. Okay, this is the cell representation of a fuel cell. Next, in fuel cell, what is happening at anode? Okay, remember in any cell or in any device, okay, remember in any device, anode undergoes oxidation reaction. Remember this. Okay, next, at cathode undergoes reduction reaction. Cathode undergoes reduction reaction. Okay, so what is oxidation and what is reduction? Oxidation is nothing but loss of electrons. Okay, oxidation is nothing but loss of electrons. Next, reduction is nothing but gain of electrons. Gain of electrons. Okay, so at anode, fuel undergoes. Who is there at anode? Fuel is there, right? So now this fuel undergoes which reaction? Oxidation reaction. It undergoes the oxidation reaction. Okay, so finally it gives the oxidation product and the electrons. So what is happening at anode? You can see this is one anode, electrolyte solution, and cathode, right? During the cell reaction at anode, which reaction is taking place? Oxidation reaction is taking place. That means loss of electrons. Okay, now at reduction, okay, so at cathode, which reaction is taking place? Reduction reaction is taking place. What do you mean by reduction? Gain of electrons. From where these electrons are coming to cathode? From the anode. So the electrons lost by anode, the electrons lost by the anode travel through the circuit and come to the cathode. Okay, so this comes to the cathode. Okay, whatever the electrons coming from the anode, cathode will be gaining it. Okay, it will be taking the electrons from the anode. So at cathode, reduction reaction is taking place, and it gives, that means oxidant plus electrons gives the reduction products. Next, the electrons liberated from the oxidation process at the anode can perform a useful work. That means it gives the electricity flow of electrons. Okay, now we have understood what is a fuel cell and how it's a construction, what are the major components. That means what is an anode, what is a cathode, who is there at anode? Fuel is there, and what is there at cathode? Oxidizer is there. So what this oxidizer will do? It oxidizes the fuel. Okay, this is the basic construction we have seen for a fuel cell. And remember, in before slide we have seen the examples of fuel cell, right? Hydrogen oxygen fuel cell, molten carbonate fuel cell, like etc. Okay, so in our syllabus we have the most important type of fuel cell, that is hydrogen oxygen fuel cell. Okay, hydrogen oxygen fuel cell. So from the name it indicates that hydrogen is your fuel. Hydrogen is your fuel, and oxygen is your oxidizer. Okay, oxidizer. Okay, so you have, from the name itself you have understood what is a fuel and what is your oxidizer. So the fuel cell, that is hydrogen oxygen fuel cell, is most important type of fuel cell, and it is a most successful fuel cell. Okay, it is a most successful fuel cell. Now, construction of fuel cell, how it is constructed, we'll see. A cell contains a two porous carbon electrodes. It contains a two porous carbon electrodes. So this is one your electrode and this is one your electrode. Okay, so as we know, this is the anode and this is your cathode, right? So it contains a two porous electrodes, that is anode and cathode. Next, how these electrodes are made by? It is made by a carbon, that is a compressed carbon, and it is coated, or it is surfaced, like a surface is coated with some amount of catalyst, like platinum, palladium or the silver. Okay, anything we can use. So in our thing, we are going to take a anode, cathode, that is made by it is a porous carbon, and the carbon is also a compressed carbon, and it is coated with a catalyst, a small amount of catalyst, that is platinum, palladium or silver. Understood? Okay. Now, between the two electrodes, electrolyte solution is present, and the electrolyte solution we have taken here is 25% of potassium hydroxide. Okay, so here we have taken 25% of potassium hydroxide. Okay, now we'll see a working of hydrogen oxygen fuel cell, how it works. So what is there at anode? I said hydrogen is there, and what is this hydrogen? Fuel. What is this hydrogen? It is a fuel. And what is this oxygen? It is a oxidizer. It is a oxidizer. Okay, now hydrogen passes through the anodic compartment. Okay, so from this inlet, this hydrogen passes through the anodic compartment where it is oxidized. Why it is called oxidized? Because the anode fuel undergoes the oxidation reaction. Oxidation reaction is nothing but loss of electrons. Okay, so when hydrogen passes through the anodic compartment, it is getting oxidized. Understood? Next, the oxygen coming from this cathodic compartment, where it is reduced. During working of fuel cell, oxidation reaction and the reduction reaction takes place near the anode and cathode. Oxidation reaction takes place by the fuel, that is nothing but your hydrogen. We are taking a fuel as a hydrogen gas. Okay, we are taking a fuel as a hydrogen gas, and here we are taking oxygen as the oxidizer as the oxygen. Okay, so when these two reactions, when reaction is taking place, we get a water molecule out. We'll see how it comes. So this is your cathodic compartment, this is your anodic compartment. Okay, from here you can see the inlet of hydrogen gas. Okay, from the anodic compartment. Now from here you can see the passage of oxygen gas. Here hydrogen and here is the oxygen. Okay, this is your cathodic compartment, this is your anodic compartment. As I said, it is made by like these anode and cathode are covered or the encapsulated by using of some amount of catalyst. Okay, now the middle, the between of anode and cathode is a electrolyte solution that we are taking 25% of KOH solution. Okay, now the catalyst present near the electrodes will help in the splitting of hydrogen gas into the protons and electrons. What? protons and electrons. Okay, protons and electrons. So the catalyst will help the coming hydrogen gas to split into protons and electrons. So just we'll watch the video. So hydrogen is inlet and oxygen, and this is how the water molecules are removed out. Okay, water molecules are removed out, and total net reaction we get is a hydrogen plus oxygen, we get a water molecule. Now we'll see cell reaction. Okay, so at anode, as we know, oxidation is taking place. That means electron, like loss of electrons are taking place at the anode, that is fuel. Okay, so here fuel, what is it? Hydrogen. Okay, hydrogen molecule gets split. Okay, when hydrogen molecules are taken to the anodic compartment, okay, these hydrogen molecules will move to the PEM. As I said, PEM means what? Proton exchange membrane. Okay, proton exchange membrane. So when these hydrogen molecules come to the PEM, the catalyst near the electrodes will split the hydrogen molecules into protons and electrons. Okay, protons and electrons. This is what protons and electrons. Okay, now this protons pass through the electrolyte solution. That means it passes through the PEM membrane or the electrolyte solution. Protons will exchange. See, from the hydrogen molecule you are getting protons and electrons, right? So only protons are moving from the membrane, only protons. That means ions only. Ions will pass through the electrolyte solution. What these electrons will do? It will flow through the external circuit. It will flow through the external circuit. Next, cathode. What the cathode does, whatever the electrons and ions coming from the anode, it will be gaining it. So what is coming from the anode? Electrons and protons, right? So along with the oxygen, at cathode who is there? Oxygen is there. And what are coming through cathode, like what are coming to cathode? Protons and electrons. So the electrons, protons, oxygen, these all combine to form a water molecule. Now we understood how we get a water molecule, right, from the fuel cell. Okay, so first the anode will be giving out protons through the electrolyte solution and electrons to the circuit. It comes to the cathode, and oxygen near cathode receives the protons and electrons combine and give a product, that is water molecule. You can see here water molecule is coming out. Okay, water molecule is coming out. Okay, so if you observe the cell reaction at anode, what is happening? A hydrogen molecule is splitting out into protons and electrons. Okay, at cathode, who is there? Oxygen. It receives the protons and electrons from the anode and finally produces a water molecule. So overall reaction here we have 2H2 plus O2 gives rise to 2H2O. Okay, so this is how we get a water molecule. So we get a oxidation product as a water molecule, and also here it is produced electricity. Okay, so as we have seen in a before slide, see, a fuel, oxygen, these two are combined to produce a oxidation product. Now what is the product we get? Water molecule, and also it gives the electricity. Okay, these are the cell reactions. Now we'll see the applications of hydrogen oxygen fuel cell, how it is applied in the Well, okay. So the first commercial use of a fuel cell was in NASA space program to generate the power for satellites and space capsules. Okay, satellites and space capsules. Okay, for generating power, they have first used in NASA space program. Okay, and also because of this lightweight. Okay, because of this lightweight, this is used for the pure drinking water. Okay, for the drinking water, as we have said, it is used in space, right, for the power generation. Okay, along with power generation, it produces the water molecules or the water. Okay, that water is used for the drinking purpose for the astronauts in the space. Okay, it is also the one of the applications of hydrogen oxygen fuel cell. Okay, so they are highly useful in spacecrafts, okay, as a drinking water and also for the power generation. And also it is used to power fuel cell vehicles, as we have a lithium ion battery vehicles, right? Same way we also have a fuel cell vehicles that includes the automobiles, aeroplanes, boats and submarines. Okay, so you can see a car made up of a fuel cell. Okay, and in the submarines and also the buses or the vehicles. Okay, this is one of the application of hydrogen oxygen fuel cell. Okay, next topic we have is difference between fuel cell and a battery. Till now we have discussed about a batteries and also the fuel cell. Yes, under batteries we have discussed like what is a primary, what is a secondary, and under fuel cell we have seen one of the most important type of fuel cell, that is hydrogen oxygen fuel cell. Now we have idea what is a battery, what is a fuel cell, right? So now we'll see some of the differences between the battery and fuel cell. Okay, so coming to the battery, it stores and releases the electrical energy through the chemical reactions. But here is the electrochemical reactions. It generates the electricity. Okay. Next, contains the all necessary components internally. Okay. We will not remove a battery and again we put it, right, for any other components to include. Okay, because all the components are whatever necessary for the working of battery is put inside first only. Okay, but coming to the fuel cell, it is not like this, because the hydrogen oxygen, that means a fuel and oxidizer, we call it as a reactants. Okay, we call it as a reactants. Okay, and this is your product, this is your product, this is your reactants, it is your product. So coming to the fuel cell, okay, the reactants should be supplied, reactants and the electrolyte also, reactants and the electrolyte should be supplied continuously until and then it gives the products. Okay, so if you stop supplying the reactants and products to the fuel cell, it will stop giving your products. Okay, so to get your product or to get your cell working or to generate the power, okay, what you have to do, you have to continuously give the reactants and the electrolytes to the fuel cell. But in case of battery, if you observe, we put all the things or the components inside first or necessary. Okay, like we do not give the reactants or the electrolyte again and again. If we put for the charging, it gets charged and it works. But coming to the fuel cell, it is not the thing, because the reactants and the electrolyte should be supplied continuously. Okay, so use external fuel source such as hydrogen. Next, stores energy and releases when needed. Okay, produces the electricity as long as I said, as long as you give reactants to it, then and only it produces the energy. If you stop giving it, it will stop producing the energy. Next, energy density can vary but generally lower. Okay, compared to the fuel cell, the energy density of a battery is low. Okay, it is a low. Coming to the fuel cell, it is having a higher energy density. It is having a higher energy density. So this is the difference between the battery and the fuel cell. So next topic we have in our battery chemistry module, that is solar cell. Okay, I think many of you have seen the solar cell or the heard about the solar cell. Yes, so can you see a picture of the solar cell here? So these are nothing but your solar modules or the solar panels. Okay, so first of all, what do you mean by, see, this is nothing but this, whatever you are seeing is a solar panel or the module. Okay, solar cell is nothing but each single unit, we call it as solar cell. Solar cell. Okay, a single unit we call it as a solar cell. Okay, even the solar cell will take the light energy, that means it uses the light energy to produce the electricity. That means it converts the light energy and light energy to the electrical energy. Okay, it converts the light energy to the electrical energy. So it is a device that converts the energy of light into electricity by using a photovoltaic effect. Okay, so what do you mean by photovoltaic effect? It is the generation of voltage across the p-n junction in semiconductor. If you take any silicon semiconductor, you are going to have a p-type semiconductor and n-type semiconductor, right? So between p-type, n-type, combined, like we call it as p-n junction. Okay, the junction between the p and n type semiconductor, we call it as p-n junction. So the voltage which develops at the p-n junction, okay, due to the absorption of light radiation, is called as photovoltaic effect. And the solar cell, you can also call it as photovoltaic cell. Okay, the other name for solar cell is photovoltaic cell. Now we'll see the construction of solar cell, how it is constructed or how it is made by. Okay, a solar cell is made by a semiconductor. Okay, solar cell is made by semiconductor, that is silicon semiconductor. So you know semiconductor means it consisting of a n-type semiconductor and also a p-type semiconductor. So in n-type semiconductor, it is having major concentration of electrons. Okay, n-type semiconductor. Coming to the p-type semiconductor, it is having major concentration of holes. Okay, now the two layers are sandwich. You can see the picture like, okay, it is in a sandwich model, and hence there is a formation of junction, p-n junction. Okay, that is nothing but your p-n junction. You can see a down one. Okay, the down part is a p-type material or a p-type semiconductor, and the above part is a n-type material, that is n-type semiconductor, and the junction between these two semiconductors, we call it as p-n junction. Okay, p-n junction. This is the construction of a solar cell. That means solar cell is made by a semiconductor. Majorly we take it as a silicon semiconductors. So semiconductor, it is having a p-type and n-type. What I said, in n-type, who is there? Electrons will be present, and in p-type, holes will be present. Okay, now the surface of the cell, okay, the surface of the cell is coated with the anti-reflection coating. Anti-reflection coating. So if you take a cell or a semiconductor, we have a front contact, what we call it as front contact, and this is the base contact. In between, you are going to have a n-type semiconductor and p-type semiconductor, and the middle one, we call it as a p-n junction. p-n junction. Okay, so the front contact is made by, you can see here, conducting strips, or the front contact is made by anti-reflection coating. Okay, anti-reflection coating. Why we are doing this coating is to avoid the loss of incident light energy. The main component what we want here is a light energy, right? The light rays should fall on the cell. Okay, so we are coating this thing with the anti-reflection because the incident rays should not escape out. Okay, it should not escape out. That is why it is coated with the anti-reflection. Okay, next, a proper metal contacts are made on the N-type and P-type side of semiconductor for electrical connection. Okay, so this is our model, right? So these are connected to a circuit. These are connected to a circuit for the electrical connection. For the electrical connection. So if you see in this picture, so this is your N-type, the blue one is your N-type and the below one is your P-type. Okay, N-type and P-type. Okay, the above is coated with the anti-reflection coating and the below is a substrate base. Okay, the sun rays from the sun or the light rays from the sun fall on the cell, and where electrons move through this circuit and it generates the electricity. Okay, now working of solar cell will see. So when solar panel, so as I said here, a single unit we call it as solar cell, right? So a single cell like this cell will give you a 0.5 volts like that. Okay, it gives you a 0.5 volts. Okay, somewhat lower, right? So when we want a high amount of voltage or high amount of electricity, we connect all these cells together, and that we call it as a solar panel. Okay, so how these solar cells are connected like this? Okay, this we call it as a solar panel. That means it gives the high amount of electricity and high amount of voltage. Okay, so suppose the 30 solar cells will give you a 15 volts. Okay, it gives you a 15 volts. Now you understood what is a solar panel, right? When a solar panel exposed to sunlight, the light energies are absorbed by a semiconductor materials. That means whatever the P-type, N-type, the material is there, that is absorbing the light energy coming from the sunlight. Due to this absorbed energy, the electrons are liberated and produces the external DC current. Okay, it gives you a direct current, and the direct current is converted into a 240 volts. Okay, so if you see this, the photons, from where the photons will come? From the light rays or the light energy from the sunlight. Okay, when the light rays fall on the panel, the electrons in the N-type semiconductor start moving through the external circuit and reach the P-type semiconductor by giving you a bulb glowing or the producing your electricity. Okay, this is the working of solar cell. Okay, see how it is moving. So the rays are falling on. Okay, this is the working of solar cell. Now we'll see the advantages of solar cell. So first advantage is what? It's a pollution free. Okay, it is a pollution free and it is clean. Okay, next it is a renewable energy. That means we get a plenty of light rays, plenty of energy from the sun, right? It will not exhaust. Okay, so that is why we call it as renewable energy. Okay, and environment friendly. Okay, next, solar cells do not produce the noise and they are totally silent, and they require a very little maintenance. These are the advantages of solar cell. Now we are coming to the applications of solar cell. Okay, applications of solar cell. We have many applications of solar cell, like building heat, like building of building using of solar cell, and also for the solar heating of buildings, and also for the distillation of water, and also for the drying of agricultural products, etc. Okay, so first we have is solar water heating. Okay, so have you seen this picture? I think you have seen this in your like houses or buildings, this is used for the warming of your water to get a hot water. Okay, so it is one of the applications for the solar cell. Like solar water heating systems or the solar thermal systems use energy from the sun to warm water. Okay, it takes the light rays from the sun. Okay, so solar panel absorbs the light rays and it converts the cold water into a warm water. Okay, by this type of cylinders. Okay, so we are going to get a hot water like this. Okay, it is one of the application of solar cell. Now, solar heating of buildings, as I said, collecting the solar radiation in some of the countries in cold areas, they are using these solar panels to heat the building. Okay, to heat the building. So how they collecting the solar radiation by some element of building. Okay, from one side of the building or from some like any windows, they are going to collect the solar radiation from the building itself, and this solar energy is admitted directly into the building through the large south facing windows. Okay, so this is how a sun rays are falling and the heat is distributed over the house. Okay, it is one of the application like solar heating of buildings. Okay, next, one more application is like solar distillation. Okay, that means we are going to use the light energy from the sun. Okay, this light energy is absorbed by the solar panel and it is helping in converting the pure water. Okay, it is going to help to give a pure water or a potable water. So say in some of the coastal areas there is a scarcity of the potable water. What do you mean by potable water? Potable water is nothing but your drinking water. Nothing but drinking water. Okay, in some of areas the scarcity of this potable water are there. So in that area what they are doing is abundant sunlight in these areas can be used for converting saline water, that means salt water, saline water, into a potable distilled water. Now this water, this is how a real unit will be looking like. Okay, this is your solar panel. Okay, now the distilled water is collected and it is used for the drinking purpose. Okay, it is one of the application of solar cell, and here we get it through a vapors. Okay, one more application we have is solar pumping. Okay, so by using of this solar cell, we are going to generate the power. By solar energy is like by using of solar energy. Okay, and this pumping water for irrigation purpose in our farm plants. Okay, so it is going to give a water, or it is going to give a pump the water by using of this solar panels. Okay, next, one more type of application we have is for the solar cell is by using of this solar panels or the cells, we are going to dry the agricultural and animal products. Okay, agricultural and animal products. Okay, this is a traditional method of utilizing solar energy for drying of agricultural and animal products. You can see here, right? So this is how they place a solar panels. Okay, inside they place the products of agricultural products and they dry it. Okay, now one more application we have is solar cooking. Okay, one more application we have is solar cooking. By using of same the light energy, solar cell or panel, it will cook the products. Okay, so a solar cooker is a device that uses the energy from the sun. This is how we made. Okay, this is how we will be made, like aluminum foil we keep. Okay, the device uses the energy from sun for the cooking purpose. Okay, if we keep a cooker like this, okay, from the energy of light it gets start cooking. Okay, for the various purposes too. Okay, so this is how it looks like. So cook pot we put it here and the glass or plastic cover we close it with it, and it is also covered by a black colored interior. Okay, inside. Okay, this is a solar cooker. So this is the applications for the solar cell. So till now we have discussed like what is a solar cell and how it is constructed and how it is working, and also the applications of solar cell. And before we have discussed is fuel cell and its construction and working. These two we have covered in this session, and the next topic we have is corrosion. This we will discuss in the next class. Okay, so in next class we are going to discuss the corrosion. What do you mean by corrosion, how it is caused, okay, if once it is caused, how we are going to prevent it, okay, and what are the prevention methods we have, okay, and by the corrosion of metals, what are the disadvantages we have, how the metals are destructed, okay, these are all things we are going to see in the next class. Thank you.